Welcome back. In this video, we're going to do a quick review of substitution reactions. We'll start off with a really simple one here. We have a primary bromide and an iodide, which is a really good nucleophile. So Oscar, this one's easy. It's just a simple substitution reaction where the iodide comes over, kicks out the bromide. Now, what if we make this a little bit more complex by going to a secondary system? In a secondary system, of course, we need to add our bromide to a carbon which is indeed going to become asymmetric. We added to the middle one here, it would not be a chiral molecule, so I'll add the bromide right here. We'll do our reaction, and of course again it's a simple displacement. But what we're doing here is losing the fun of it because there's stereochemistry involved. So let me go in here and choose a particular isomer for the bromide here. So what is it now? This is this. I get out my hand, I can see this is a left-handed system. So if we do the reaction now, what is done, of course, is reversed it now when we have a right-handed system. So this goes with inversion, backside attack, inverts that carbon, flips all the stereochemistry around. Now this is good SN2 chemistry. What if we change our nucleophile? Let's go to something a little more basic. So I'll make this a hydroxide. So is that going to invert? What's going on? And oh, well, nothing went on for substitution. We got elimination as well instead. And when you go to these SN2 reactions with a strong base like hydroxide, elimination is always possible. Primary, you can usually get away with it, but as soon as you go to secondary and certainly tertiary, elimination is almost certainly going to take over unless you're really careful doing at low temperatures or something like that. So let's look at the primary one. Here we go back to the primary one. Now, of course, I got to lose that wedge. It doesn't make any sense. Let me erase the product. Do this reaction. Of course, now you can get away with it. It's simple substitution comes back. What about other nucleophiles could you try? We could do a sulfide. That works fine. Let me make a methyl sulfide, which is a pretty good nucleophile. That works well. We could do a triple bond. Okay, an acetylide. Let me. Here we have an acetylide. This would be like a lithium acetylide, sodium acetylide. This works fine for primary. Okay. What about doing a secondary? So let me go to a secondary system. What's going to happen here? Well, again, we're going to have elimination. This acetylide is a much stronger base than hydroxide. So if hydroxide did elimination, acetylide is guaranteed to do elimination. So there's just no way you can do this. What about a really poor nucleophile? Fluoride. Okay, fluoride is not a good nucleophile at all. We try to do this reaction to fluoride. What's going to happen? Well, no reaction. Now, this no reaction. No, there's a bit of a problem here. Is I haven't specified a solvent, and Oscar, when you just give it a reaction, it's assuming on these things actually that you're using an alcohol or something, a protic solvent, because that's the way we kind of learn about substitution reactions. But what if we go up here and we actually specify that this is a polar aprotic solvent? So I'm going to add a polar aprotic flag on here. Now I do the reaction. Well, as soon as you go to polar aprotic solvent, fluoride's nucleophilicity goes way up because the fluoride isn't stabilized by hydrogen bonding. So it becomes a good nucleophile. And so that kind of saves the day. Now, one thing I haven't talked about at all is tertiary systems. So let's come and look at some tertiary systems. So as soon as I go to this bromide, okay. Now if I don't want the fluoride there, I want a carbon. Okay, so let's go back to our iodide. Now we have our iodide is a good nucleophile, and it's a tertiary system. And will this work? Well, it does work. I'm sorry, it doesn't work because you can't do your SN2 reaction simply because there's no possibility doing a backside attack on the tertiary center. So these reactions simply don't go. Now what you have to do for these is you have to go. You can do SN1 reactions if you're under more hydrolysis conditions. And so if we come back and we don't use an iodide, what we use instead is, well, let's just use water. Okay, this is simply hydrolysis now. Now what Oscar is showing here is we get a mix under the hydrolysis conditions. We get SN1 substitution, but is pointing out that you often get along with this substitution reaction, you often get an E1 elimination, and so you make some double bond. So these things are a little bit tricky. Now you change that water to a methanol, you can of course expect if something very similar, where now we make a methyl ether and an alkene. So these things can get a little bit wild. Now another really important family of reactions to look at are alcohols, where we're actually trying to do a substitution of an OH group. Now let me not start with the tertiary one. Let me go back and we'll start with primary. So here's our primary group, and we're going to try to do a substitution of this. Now if you just use iodide, okay, it's a very good nucleophile, what do you get? Well, you get nothing. There's no reaction. But if instead of using the iodide, let's use HI. Now we do the reaction works. Why does it work differently? Well, because the leaving group is no longer hydroxide. Hydroxide's a terrible leaving group. But if you protonate it with the HI, now you have a water out there. It's an oxonium ion. The iodide can displace it very easily. So this works. How about a secondary system? So we go to secondary system. Again, we change that to carbon. We're going to wipe this out, do the reaction. This works fine. Again, it's secondary. You got to be a little bit careful that you're going to get some elimination as well. If we go to a tertiary, this will work, and again, you may have some elimination, but these SN1 reactions seem to work pretty well. And one thing, if you do have elimination, you have HI around, of course the HI will just add to the double bond, and so you don't really have to worry about the elimination problem so much. Now one thing, of course, you do have to worry about in these systems is the unexpected. And so let me take the hydroxide and let me move it over. Okay, let's say we had the hydroxide here. Okay, so now if I do that reaction, what do I get? Well, of course, I'm setting you up for this. We're going to get a rearrangement, because in this case, this is SN1 condition, so the OH leaves, you'd make a secondary carbocation, but of course, as that secondary carbocation is forming, you'll get a hydride shift from the tertiary center, so you'll end up again with a tertiary system. So rearrangements are a very common thing in these reactions with alcohols. Anytime you're making a carbocation and you can do a rearrangement to make a more stable one, you basically expect to see that. So these are some of the basics of substitution. There's a lot more to it, of course, but it's enough to get you back on the right track thinking about these things, because the next thing we're going to do, of course, is turn around and look at additions instead of elimination.